The learning target for this video is learn how to identify and name type 2 ionic binary compounds. So let's first talk about how you can identify type 2 ionic compounds. Type 2 compounds, like type 1 compounds, are going to be between metals and nonmetals. The difference between type 2 compounds is that the metal is a transition metal. And if you're not sure where the transition metals are, they pretty much start where the S block ends, and then they go all the way over to the staircase. So all of those metals are transition metals. And you'll notice that I've purposely skipped aluminum. Aluminum is not a transition metal. It is a type 1 compound. It's a type 1 metal. And it always has a charge of +3. The only real difference between type 1 and type 2 naming is that type 2 naming will always have Roman numerals in their names. And the Roman numerals are there to indicate the charge of the atom or the metal. And the reason we need to indicate the charge of the metal is because all of these metals, or just about all of these metals, have multiple charges that they can make. For example, iron can sometimes be +3, other times it can be +2, and it can even be +1. So depending on which iron we're talking about, we're going to have to indicate that with a Roman numeral in the name. And the Roman numerals you're going to have to know, if you don't know them already, are Roman numerals 1 through 6. So make sure you know what each of these Roman numerals are. That's 1, 2, 3, 4, 5, and 6. Other than the Roman numeral, type 2 compounds are named the same, which means we're always going to name the metal first and then the non-metal with "ide". So again, the thing that makes transition metals so much different than group 1, 2, or group 3 metals is group 1, 2, and 3 metals always have the same charge. Lithium is always +1. Magnesium is always +2. And as I said before, aluminum is always +3. Whereas these transition metals, most of them have multiple charges that they can be. So what I want to do is use the practice set that I've given you. I've given you 5 different compounds, and I want to go through how to name these compounds and how to determine the charge of the metal. In A, we have MnO2. First off, the way we can identify that this is a type 2 compound is the metal, Mn. If we go back to the periodic table here, it may be kind of hard to see. I'll erase in that area. There is Mn. It's number 25. So there's Mn. It's definitely a transition metal or a D block metal, which makes this a type 2 compound. The way we're going to come up with a name for this compound, we know that this compound is going to be called manganese oxide. I'm leaving a big space in the middle here, and that's for the Roman numeral that we're going to use to show what the charge is on manganese. The way we're going to determine the charge is by looking at the nonmetal. We know that one oxygen has a -2 charge, and here we have 2 oxygens, which means the total negative charge is -4. And like all ionic compounds, your charges are going to have to equal 0 when added up. So if the oxygen charge, if oxygen is bringing to the table a -4 charge, that means that manganese has to have a charge of +4 in order to equal 0. So we're dealing with manganese with a charge of 4. And the way we write this in a compound is we put parentheses after the metal, and then we write the Roman numeral afterwards. So this compound is called manganese 4 oxide. Alright, let's take a look at the next one. The next one is U2-L11. And again, the way I'm going to identify this, I'm going to look at the metal copper and look back at our periodic table and see where copper is on the periodic table. And there it is, it's number 29. There's copper. It's definitely a D block metal, which means it's a transition metal. So I'm using type 2 naming. So I know the name of this compound is going to be copper something oxide. And remember, we're leaving this space right here for the Roman numeral for copper, because there are always Roman numerals in type 2 compounds. Now let's determine what that Roman numeral is. Chloride, we know, has a -1 charge. And we have 2 chlorides, which means chloride is bringing to the table a -2 in charge. And that means that copper has to be +2, so that those charges can equal 0. And so this must be copper 2 that we're dealing with. So the name of that compound is copper 2 oxide, not just copper oxide. The next one I've given you is CuCl. And again, we know that this is a type 2 compound because we know copper, just like in the last example, is a transition metal. And the name of this guy we know is going to be copper something chloride. Now let's figure out the charge. The chloride has a -1 charge, which means that copper must have a +1 charge in order for these charges to equal 0. So that means this is copper 1 chloride. Okay, let's take a look at it going the other direction, where you're given the name and you've got to figure out the compound. This is exactly the same way as type 1 compounds. So here's chromium 3 oxide. And just like type 1 compounds, we're going to split up this compound with a wiggly line between the metal and the nonmetal. And then we're going to write out the ions for both sides. Chromium 3 is Cr plus 3. Remember that Roman numeral is telling us the charge. It's not telling us how many chromiums there are, it's telling us the charge. Oxide is O minus 2. And just like with type 1 compounds, we're going to circle the number, not the charge, just the number, and then we're going to cross those over. And so chromium 3 oxide is Cr2O3. So there's the answer for D on the practice set. Now let's take a look at the last one on the practice set. The last one on your practice set there is manganese 5 sulfide. And because I see a metal in the name, we're going to go ahead and draw this squiggly line between the metal and nonmetal, and then we're going to write the ions for both of these. Manganese is Mn, and it tells us it has a charge of +5. Remember that metals are always charged positively. They always have a plus charge. So when it says 5, it can't be -5. It's +5. Sulfide is S minus 2. And let's go ahead and circle the numbers, not the charges, and then cross them over. So manganese 5 sulfide is Mn2O5. So there's our answer to E. Anytime you see a common factor other than 1 in the subscripts for type 1 or type 2 compounds, you need to divide and simplify those subscripts. So for example, let's say that we had a compound and it was metal, its name was metal non-metallide, and let's say that we find out that the formula is M20 NM10. Hopefully you can see that there is a common factor other than 1 between these, and that's 10. And in that case, we do need to divide both of these by 10. So that means that the final real formula is M2NM. So you always need to be dividing by those greatest common factors if you see them, as long as they are not 1. Now let's look at example F. In example F, we have chromium Vi, which is 6 oxide. And because this is a metal, we're going to go ahead, draw our squiggly line, and then write out the ions for both. Chromium 6 looks like this. Oxide looks like that. Let's circle the numbers, not the charges, just the numbers, and then cross them over. So that's going to give us Cr2O6. And hopefully you've noticed here that I've given you an example that has a common factor for both of these subscripts. That common factor is 2. So we need to divide both of these by 2 before showing our final answer, and that's going to be CrO3. So CrO3 is chromium 6 oxide, not Cr2O6. So you're going to have to be careful of that with both type 1 and type 2 compounds. Okay, let's talk really quickly about the number 1 most made mistake with type 2 compounds. This mistake is assuming that the Roman numeral is talking about the number of that atom. So for example, with that last example we did, chromium 6 oxide, remember that this 6 refers to the charge of chromium, not how many chromiums there are. This is not Cr6O. So that's the number 1 made mistake, especially with people who don't quite understand what type 2 compounds are all about. Alright, let's take a look at the problems I've given you now. The first one is Ni2O3, and we need to come up with a name for this. First off, we can identify this as a type 2 ionic compound because nickel is a transition metal. Now that we know that, let's go ahead and figure out what the charge of nickel is. So oxygen, each oxygen has a -2 charge, and we have 3 of them. So that's a -6 total charge, which means that the total charge coming from the 2 nickels has to be +6. And notice I said the total charge coming from the 2 nickels has to be +6. That means that each nickel that we're dealing with is a +3 nickel, not +6. So the name of this compound is nickel 3 oxide. Okay, in the next example here we have NiCl3. And again, we know that this is a type 2 ionic compound because it has nickel in it. Each chloride is -1, so 3 chlorides is -3. And remember that this has to equal 0. That means that nickel must be +3. So this compound is nickel 3 chloride. Okay, the next example I have for you is PbS. And again, we can identify this as a transition metal if we go back to our periodic table and look where lead is. Here is lead. It's number 82, so it's in the transition metal area. It's not a D block metal, but it is a transition metal. Okay, sulfur has a -2 charge, which means that this lead must be +2. So this compound must be lead 2 sulfide. Okay, in the next problems, we have names and we've got to figure out the formula. So, ruthenium 4 chloride. Ruthenium is a metal, so we're going to go ahead and draw a squiggly line. Ruthenium 4 is Ru plus 4. Chloride is Cl minus 1. And there are our numbers, and now we're going to cross those over. So ruthenium 4 chloride is RuCl4. The next one I have for you is rust. Rust is iron 3 oxide. And again, iron we know is a metal, so we're going to go ahead and draw this squiggly line. O minus 2 and Fe plus 3. The numbers are 3 and 2, and let's cross those over. So iron 3 oxide is Fe2O3. Okay, the last example is vanadium 5 oxide. Vanadium 5 oxide. Vanadium is a metal, so we're going to draw our squiggly line. Vanadium 5 is V plus 5. Oxide is O minus 2. Let's go ahead and take those numbers and cross them over. So vanadium 5 oxide is V2O5. When you get to class, I expect you to be able to name type 2 ionic compounds. And also, given the name of a type 2 ionic compound with a Roman numeral in it, I expect you to tell me what the formula is. So you should be able to do this after this video with binary compounds. Binary compounds are just compounds with 2 different elements in them.